Hello, this is Math 2270 coming to you from the College of DuPage during the summer of 2020. And this is the conclusion of the lecture entitled The Heaviside Step Function and Laplace Transform. When last we left, you were working on computing the inverse Laplace transforms for each of the following. I hope you were able to complete this, but if not, you know what to do. Let's see how you did. So here is the capital H of S, and we want to find the inverse Laplace transform. Well, it makes sense just to strip out this e to the minus 4s because that's going to be a Heaviside step function whenever we invert the transform. And so I've stripped that out. Look at this, and I call this f of s. And this f of s is going to receive most of our focus because it's going to be an integral part of our answer, and this is just going to be the step function that we have at the end of this. So let's focus on f of s. Now f of s then is going to be s over 3s plus 2, and this is s minus 2. And so if we do partial fractions on that, we will get that f of s is equal to 1/4 over 3. Actually, that's going to be 1 over 12. S plus 2 over 3 plus 1 over 4, and that is s minus 2. And so this is an easy transform for us to invert. We should be pretty good at this now. And we get that f of t then is equal to 1 over 12 e to the minus 2 over 3t plus 1 over 4 e to the 2t. Now we have to remember though that our original problem was this one, so that means that our answer is going to be h of t, which is the transform of this one, the inverse transform of that one, is going to be this one is going to give us the Heaviside step function u4 of t times t minus 4. This shift is important. And so you see the real answer to the problem then is h of t is equal to Heaviside step function sub 4 of t. And then this is going to be f of t minus 4. So you see I write f of t here, but I substitute t minus 4 instead of t. Lots of algebra in this problem. Here's the next one that you worked on. And let's do some algebra to start with. This is what we started with, but if we look at this and this, we see that this part is the same as this part. That's a common factor, so I can factor it out. And this part is really just going to be Heaviside step functions times this, and I'm going to call this capital F of x, and we're going to focus on this part, and then we'll put together the entire solution in a moment. So capital F of s then is 1 over this, but I can now use partial fractions to determine that. Capital F of s is this, and here I'll break this into two terms, this part, and so capital F of s is 1 over 13, 1 over s plus 2 minus s over s squared plus 9, plus this is 2. Now here I'm looking to have 3 over s squared plus 3 squared, so I'm going to have to multiply top and bottom by 3 to make it look like that, and the 2/3 is just going to be a constant that we'll factor out. And so this is what we get for f of s, and this is easily inverted using the inverse transforms, and we will get this. This is going to be e to the minus 2. This is going to be cosine of 3t. This is going to be 2/3 sine of 3t. Now putting together my original g of s from here, I have this, and I'll distribute that again, so I will have this. Now when I invert g of s, I will get g of t is equal to 5. When I invert this, I'll get Heaviside step function u sub 6 at t, and this is going to be f, and f is up here, at t minus 6 minus 3 times u at u Heaviside step function 11 at t times f of t minus 11. Now I want everyone to realize that this answer says that this in expanded form would be 5u sub 6 of t, and then is going to be times 1 over 13 e to the minus 2 times t minus 6 in the exponent. And this would be minus cosine 3 times, in parentheses, t minus 6, plus 2/3 sine of 3, and this would be t minus 6. That gets us to here, minus, and then this is going to be 3 times Heaviside step function 11 of t, and this is going to be f at t minus 11. So that's going to be this one times, it's going to be 1 over 13 e to the minus 2 parentheses t minus 11 minus cosine of 3 parentheses t minus 11 plus 2/3 sine of t times 3 minus 11. So that's quite an answer to write out, but that is the inverse transform. Let's do another one. Let's do this one. Now we're going to break this into two parts. This is the sum, and so I will write it this way and this way. Notice that there's a Heaviside step function factor only on one of these, so this is going to be g of s, and this is g of s right here, and this is e to the minus s times what I'm calling h of s. Now, so that's what we have, and so we will go through and do the calculations. And so what we'll get, and notice that there's an s over here, that's why that's different. It's not the same thing. There's s over this, it's 4s over that. Okay, so g of s then is going to be, when you do partial fractions, is going to be 4 over 3 s minus 1, 8 over 3 over s plus 2, and when you do the inverse Laplace transform of those, you will get this as your g of t. We'll do the same process for h, and this is h, but we will get that h of s is 1/3 over s minus 1 minus 1/3 over s plus 2. That means h of t is equal to 1/3 e to the t minus 1/3 e to the minus 2t. Now let's remember the problem was to invert this one, and it was really g of s plus e to the minus s h of t. So when I invert this, I am going to just get for this one g of t, but here I'm going to get u sub 1 of t, the Heaviside step function at 1, but this is going to be h of t minus 1. And again, this was what we had for h, this is what we have for g. So let's talk about what the solution then is. The solution is going to be 4/3 e to the t plus 8/3 e to the minus 2t plus the Heaviside step function times 1/3 e to the t minus 1 minus 1/3 e to the minus 2 times t minus 1 in the exponent. One more example, and then I think we're finished with this. So this is the expression that we started with. We want to find the inverse transform of this. You have to do some working and thinking with this. And a clever thing to do is to do some, I'm going to call it group factoring, but you factor an s out of these two terms in the numerator, and you leave these alone. And then we're going to take this term divided by this plus this term divided by this. Now notice when I take this term divided by this that there's an s that cancels. This s will cancel with that s in this term. So I have this factor times this plus this times this. I'm going to call this capital F of S, and we'll worry about doing the transform of that. We will call this one capital H of S, and we'll worry about doing the transform of that. Now, F of S is this one right here. We do partial fractions on that, and we get that capital F of S is equal to 1/3 over S minus 1/3 over S plus 3. And lowercase f of t, the inverse transform of that, is going to be 1/3 minus 1/3 over e to the minus 3t. H is going to work similarly, except it's a different denominator, so it's going to be minus 1 over 9s plus 1 over 3s squared plus 1 over 9s plus 3. And the inverse Laplace transform of that is going to be minus 1 over 9 plus 1 over 3t plus 1 over 9 e to the minus 3t. Now let's remember what our original function was. It was up here, and so we realize that this is going to be, and I'm distributing here, it's going to be 3 times f of s minus 2 e to the minus 3s f of s plus 8 e to the minus 20s h of s plus 6 e to the minus 7 s times capital H of s. And then we're going to invert all of these transforms, and we've already done all the work, so our final answer is going to be g of t, the inverse transform. This is going to be 3f of t minus 2 Heaviside 3 of t, f at t minus 3 plus 8 u 20 of t, h of t minus 20 plus 6 u 7 of t, h of t minus 7. Now realize when you expand that, that means you're going to have 3 times 1/3 minus 1/3 e to the minus 3t minus 2 Heaviside 3 of t, and then it is going to be times 1/3 minus 1/3 e to the minus 3, and the exponent is going to be minus 3 parentheses t minus 3, plus this is going to be the Heaviside function 20t, evaluate, and then times h of, and this is going to be minus 1 over 9 plus 1 over 3 times t minus 20 plus 1 over 9 e to the minus 3 times the quantity 3 minus t minus 20 in the exponent, plus this is going to be 6 times the Heaviside function 7t, and then this is going to be times minus 1 over 9 plus 1 over 3, this is going to be t minus 7, plus 1 over 9, that is e to the minus 3 parentheses t minus 7. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.